AWS Certified Machine Learning Engineer Associate. This exam validates your technical ability in implementing machine learning workloads in production and operationalizing them. A data scientist is trying out different hyperparameter configurations for a machine learning model using SageMaker. Which SageMaker feature would be most helpful in tracking the performance of each trial, including metrics like accuracy, precision, and recall? Our options are SageMaker Debugger, SageMaker Experiments, SageMaker Studio, or SageMaker Pipelines. Option B, SageMaker Experiments, is the right answer here. It is the best option for tracking hyperparameter performance. It records metrics and allows for easy comparison between experiments. SageMaker Debugger is for debugging and profiling models, not comparing experiments. SageMaker Studio is a web-based IDE for machine learning development, not specifically designed for experiment tracking. SageMaker Pipelines are for automating machine learning workflows. A financial services company aims to improve its credit risk assessment model by utilizing Amazon SageMaker. They need services for data labeling and automated model training. Which of the following SageMaker services can they use to fulfill these requirements? Select two options. Our options are SageMaker Ground Truth, Autopilot, Data Wrangler, or Model Monitor. Options A and B are the right answers, that is Ground Truth and Autopilot. Ground Truth is used for data labeling, helping the company create high-quality training datasets for their models. Autopilot automates the process of model training, making it suitable for generating predictive models without extensive manual intervention. Data Wrangler primarily focuses on data preparation and does not specifically handle data labeling or automate model training. Model Monitor monitors the performance of models in production but does not assist in data labeling or model training. You are working on a machine learning project that involves processing a large dataset stored in Amazon S3. The data is queried frequently for analysis, and fast retrieval is important. You also need to minimize storage costs. Which data format would be most suitable for your use case? Select two right options. Our options are CSV, Parquet, JSON, and ORC. Of these, Parquet and ORC are the right answers. Both Parquet and ORC are columnar and highly compressed formats, which makes them efficient for fast querying on complex datasets and reduces storage costs. CSV is a row-oriented format which can make it slower to query specific columns. JSON is a flexible format that can be used to store complex data structures, but it can be less efficient than columnar formats for large datasets. Both CSV and JSON are not inherently compressed formats, therefore not optimized for reducing storage costs. Which purchasing option would allow you to optimize costs for long-term SageMaker training jobs by committing to a usage plan over a 1 or 3 year term? Our options are on-demand instances, spot instances, SageMaker savings plan, or none of the above. Option C, SageMaker Savings Plan, is the right answer here. It allows you to commit to consistent usage over 1 or 3 years, offering significant cost savings for long-term machine learning workloads. On-demand instances are more flexible but cost more without long-term commitment. It allows you to pay for compute resources you use. SageMaker also supports training jobs using managed spot training, where you can leverage spot instances, that is unused EC2 capacity, at a discounted rate. This helps reduce costs, though there is a risk of interruption. A company is preparing a dataset with categorical features to train a machine learning model. Some features have many unique categories while others are binary. Which of the following encoding techniques should they apply to effectively prepare their data? Our options are one-hot encoding, binary encoding, label encoding, or tokenization. Option A, one-hot encoding, and B, binary encoding are the right answers here. One-hot encoding is ideal for small cardinality features. It creates binary vectors, and binary encoding is efficient for high cardinality features. It reduces dimensionality with binary code. Let's look at other options. Label encoding. Although simple, label encoding assigns ordinal values which might mislead the model for non-ordinal data. and tokenization is typically used for text processing, not categorical data encoding. You want to monitor activities related to your machine learning models in Amazon SageMaker. Which of the following steps is essential to enable logging of these activities? Option A, use AWS CloudFormation. Option B, enable AWS CloudTrail and configure it to log management events for SageMaker. Option C, set up Amazon CloudWatch to monitor SageMaker instance health. Option D, use AWS Lambda. Option B is the right answer here. You can enable AWS CloudTrail and configure it to log management events for SageMaker. CloudFormation is incorrect here because that's infrastructure as code service. CloudWatch can monitor instance performance. It does not provide logging capabilities for management events that CloudTrail does. And AWS Lambda is a serverless computing service. You are building a recommendation system that requires multiple models to be deployed simultaneously. Which of the following SageMaker features would be most beneficial for managing and deploying these models efficiently? Our options are SageMaker Batch Transform, SageMaker Studio, SageMaker Multi-Model Endpoints, or SageMaker Asynchronous Inference Endpoints. Option C, SageMaker Multi-Model Endpoints is the right answer here. This feature allows multiple models to be deployed on a single endpoint, optimizing resource utilization and simplifying management for applications like recommendation systems. Other options are not specifically aimed at managing multiple models simultaneously. Therefore, they are not correct. How can company X securely share its machine learning training data stored in a S3 bucket with company Y for both console and programmatic access so that company Y can use the data to train a machine learning model? Our options are A, transfer the data to company Y's S3 bucket, B, use a bucket policy with ACLs to grant access, C, add both companies to the same AWS organization, or D, create a role in company X account with access to S3 bucket and allow company Y's account to assume that role. Option D is the right answer here. Using roles is the most secure and efficient option, allowing temporary least privilege access to company Y without duplicating data. It also provides more control over access. Option A would involve copying the data to company Y's bucket, but that's inefficient for large datasets and duplicates the data, increasing storage costs. Option B, while you could configure a resource-based bucket policy with ACLs to give the company Y access. However, this is generally a less flexible approach. Option C would involve restructuring both companies under the same AWS organization, which is impractical unless there is a close business relationship, as it implies broader administrative control. Which technique involves combining several models in a sequential manner where each new model attempts to correct the errors made by the previous models? Our options are A, ensembling, B, stacking, C, boosting, or D, bagging. Option C, boosting, is the right answer here. It's an ensemble technique that builds models sequentially, with each new model focusing on correcting the errors made by the previous ones, improving overall performance. Let's look at other options. A, ensembling is a general technique that combines predictions from multiple models to improve overall performance and reduce variance. B, stacking is a specific type of ensembling where multiple models are combined and a meta model is trained to make the final prediction based on the outputs of these models. D, bagging is an ensemble technique that reduces variance by training multiple models on different subsets of training data and averaging their predictions, which helps improve stability and accuracy. Which of the following tools can be used to optimize the instance type for a machine learning workload in Amazon SageMaker? Select two options. Our options are SageMaker Studio, SageMaker Inference Recommender, SageMaker Debugger, or AWS Compute Optimizer. Option B and D are the right answers here. SageMaker Inference Recommender analyzes machine learning models and recommends optimal instance types, while AWS Compute Optimizer analyzes a wide range of AWS resources and recommends optimizations including instance type selection. SageMaker Studio is a web-based IDE for building, training, and deploying machine learning models. It doesn't directly optimize instance types. SageMaker Debugger is a tool for debugging and profiling machine learning models. It doesn't directly optimize instance types. A data analyst at an e-commerce company is analyzing customer purchase data of several years. The analyst wants to examine the relationship between customer age and purchase frequency. Which visualization method would be most suitable for this task? Our options are scatter plot, line chart, pie chart, or bar chart. Option A, scatter plot, is the right answer here. Scatter plots are used to visualize relationship between two numerical variables, in this case customer age and purchase frequency. Line charts are typically used to show trends over time. Pie charts are used to represent parts of a whole, while bar charts are better suited for comparing categorical data. A company wants to migrate its existing machine learning models developed using Java to Amazon SageMaker for deployment and monitoring. Which approach would require the least amount of additional work or configuration for the company's machine learning engineers? Our options are A. Use SageMaker's built-in algorithm to integrate the models into SageMaker. B. Use the SageMaker SDK to import the models into SageMaker. C. Develop a custom Docker container for deploying the models in SageMaker. Or D. Using SageMaker Studio, upload the models into SageMaker. Option C is the right answer here. Creating a Docker file allows you to package the existing machine learning models into containers. This approach is flexible and provides control over the environment, minimizing operational overhead by utilizing SageMaker's ability to run custom containers. Let's look at other options. Option A. SageMaker's built-in algorithms are designed for specific tasks and would not directly integrate existing models, especially if they were trained using a different framework. Option B. Using the SageMaker SDK is primarily focused on interacting with SageMaker for tasks such as training and deploying models, but does not directly address how to bring the existing models into SageMaker with minimal overhead. Option D. While SageMaker Studio offers a user-friendly interface for building and deploying models, it does not specifically facilitate importing models without additional configuration or operational steps. You are training a machine learning model on Amazon SageMaker using a large dataset stored in Amazon S3. The training process is taking longer than expected. Which of the following strategies would be most cost-effective to reduce training time without compromising model accuracy? Option A. Increase the instance size used for training job. B. Reduce batch size. C. Optimize data loading from S3 using features like parallel data loading. Option D. Increase the number of training epochs. So option C, optimize data loading from S3 using features like parallel loading, is the right answer here. It can significantly reduce training time by minimizing I/O overhead, and increasing the instance size would likely improve performance but might be more expensive. Reducing the batch size could slow down training, especially if the batch size is already small, and increasing the number of epochs might improve accuracy but also increase the training time. Your company wants to implement predictive maintenance for its IoT devices by detecting anomalies in sensor data. The solution should automatically learn from historical data and detect unusual patterns in real time without requiring manual intervention. Which AWS service would be the best choice? Our options are Amazon Comprehend, AWS IoT Analytics, Amazon SageMaker, or Amazon Lookout for equipment. Option D, Amazon Lookout for equipment, is the right answer here. It is specifically designed for predictive maintenance by detecting anomalies in IoT sensor data, automatically learning from historical patterns. Comprehend is used for text analysis and is irrelevant to IoT or sensor data. AWS IoT Analytics provides IoT data insights but doesn't automatically detect anomalies for predictive maintenance. Amazon SageMaker can be used to build custom models, but it requires manual setup and expertise, unlike Lookout for equipment, which is designed for this use case. A company wants to analyze news articles to find common topics and themes in them. Which algorithm is most appropriate for this task? Our options are A. K-means clustering, B. Random forest, C. Sequence-to-sequence algorithm, or D. Latent Dirichlet allocation. Option D, latent Dirichlet allocation, is the right answer here. It is a topic modeling algorithm that is commonly used for discovering abstract topics within a collection of documents. Let's look at other options. A, K means clustering. It groups data into clusters. It clusters articles but doesn't identify themes. B, random forest is a supervised classification algorithm not suited for unsupervised topic modeling. C, sequence to sequence algorithm, is used for tasks like translation or summarization, not designed for topic discovery. Which AWS service allows you to set cost quotas and receive alerts when your SageMaker machine learning training expenses approach or exceed a defined limit? Our options are AWS Cost Explorer, AWS Trusted Advisor, AWS Budgets, or Amazon CloudWatch. Option C, AWS Budgets, is the right answer here. It allows you to set cost quotas and receive notifications when your usage or spending exceeds a predefined threshold, helping you control SageMaker training costs. Let's look at other options. AWS Cost Explorer provides detailed insights into your spending trends. AWS Trusted Advisor gives you cost optimization recommendations. Amazon CloudWatch is for monitoring system performance, not cost management. You need to perform complex data cleansing and feature engineering on a large data set stored on Amazon S3. Which AWS service would be most suitable choice for this task, offering a serverless user-friendly interface specifically designed for data preparation and integration with machine learning workflows? Our options are A, SageMaker Data Wrangler, B, Spark running on Amazon EMR, C, AWS Glue, or D, SageMaker Clarify. Option A, SageMaker Data Wrangler, is the right answer here. It is a visual tool for data cleansing and feature engineering integrated with SageMaker for machine learning workflows. Let's look at other options. Option B, Spark running on Amazon EMR. This is a managed service for big data processing using Apache Spark and requires more setup and management than we need here. Option C, AWS Glue, is a fully managed ETL service for automating data preparation and integration but is less user-friendly for feature engineering. Option D, SageMaker Clarify, is a service for identifying bias in machine learning models, not designed for data cleansing or feature engineering. A data engineer needs to build a real-time analytics pipeline for a social media platform that generates user activity logs. They plan to use a machine learning model on SageMaker for sentiment analysis. Which combination of AWS services should the engineer use to ingest and process the logs before sending them to SageMaker? Our options are Amazon Kinesis data streams, AWS Lambda, AWS Glue, or Amazon Kinesis data firehose. We need to select two right options, and they are option A and option D, that is Amazon Kinesis data streams and Amazon Kinesis data firehose. Kinesis data streams is a managed service for real-time data ingestion, ideal for capturing high-volume user activity logs continuously. And Kinesis data firehose can capture, process, and load streaming data into data stores for further processing. Options B and C are incorrect. While AWS Lambda and AWS Glue can be used for data processing, they are not specifically designed for real-time data ingestion and processing at the scale required for a social media platform. A company wants to enhance the accuracy of their production machine learning model without compromising its performance by training the model using additional data. Which solution requires least development effort? Option A, use SageMaker Feature Store. Option B, leverage Amazon SageMaker Model Monitor to gather new data and retrain the model. Option C, utilize Amazon SageMaker Experiments to retrain. Option D, implement Amazon SageMaker Debugger first to identify bottlenecks. So option B, leverage Amazon SageMaker Model Monitor to gather new data and retrain the model, is the right answer here. Amazon SageMaker Model Monitor is designed specifically for monitoring and improving the quality of machine learning models in production. It can automatically collect new data from the model's endpoint as it serves predictions, simplifying the process and minimizing development effort. Option A, SageMaker Feature Store, is a centralized repository for storing and managing features used in machine learning models. So that's not the right answer. Option C, SageMaker Experiments is a tool for tracking and comparing different experiments, which can be time consuming and require more manual effort. So not a good answer here. Option D, SageMaker Debugger helps identify performance bottlenecks. It doesn't directly address the need for additional data or retraining. A machine learning process requires low latency access to training data along with frequent read and write operations. Which storage service is best suited for this? Our options are Amazon EBS, EFS, FSx for Lustre, or S3. Option C, Amazon FSx for Lustre, is the right answer here. It is a high-performance file system optimized for data-intensive workloads, offering low latency and high throughput for frequent access. Relatively, other storage options do not provide an equally fast access to data for frequent read or write. A company is deploying a machine learning model using Amazon SageMaker to analyze sensitive customer data. The model must operate within a secure environment where there is no external network access. This is crucial to comply with industry regulations and protect customer information. Which solution will meet these requirements with the least operational overhead? Our options are A, configure SageMaker in VPC only mode with security group that blocks internet access. B, use SageMaker ground truth to manage labeling and training without external access. C, use SageMaker network isolation mode to prevent external network access. D, configure SageMaker in a private subnet with a network access control list to block all internet traffic. Of these, option C, use SageMaker network isolation mode, is the right answer. It provides maximum security by isolating your environment from public internet and requires minimal configuration. Other options like using ground truth are incorrect or require much more configuration, thereby increasing operational overhead. Which technique is commonly used in data preparation to ensure that a machine learning model generalizes well and reduces prediction bias? Our options are data shuffling, feature scaling, hyperparameter tuning, or cross-validation. Option A, dataset shuffling, is the right answer here. Shuffling helps to randomize the order of samples, ensuring diverse representation in training and validation sets, thus reducing bias. Feature scaling standardizes or normalizes feature values to ensure that no single feature dominates the learning process. It does not directly reduce prediction bias. Hyperparameter tuning is the process of optimizing model parameters to improve performance, but it does not specifically address bias in the data preparation stage. Cross-validation is a technique for assessing how a model will generalize to an independent dataset by partitioning the data into training and validation sets multiple times. While it helps with model evaluation, it doesn't directly prepare the data to reduce bias. A data scientist is training a large language model on a massive text dataset in Amazon SageMaker. The model is too large to be trained by a single GPU. To optimize the training process, which feature should they leverage? The options are model parallelism, pipe mode, data augmentation, or hyperparameter tuning. So option A, model parallelism, is the right answer. It splits a large model across multiple GPUs, allowing training of models that are too big for a single GPU. Let's look at other options. Pipe mode. It streams large datasets directly to the model during training, reducing memory usage by avoiding the need to load the entire dataset at once. Data augmentation increases the size and diversity of the training dataset by applying transformations. Hyperparameter tuning automatically finds the best set of hyperparameters to optimize model performance. Which of the following methods is specifically designed to reduce the training time of machine learning models by halting training when performance stops improving? Our options are early stopping, data augmentation, regularization, or transfer learning. Option A, early stopping, is the right answer here. It monitors model performance during training and stops the process when performance no longer improves, thus saving time. Data augmentation involves creating new training data samples by modifying existing data, which can improve generalization but does not directly reduce training time. Regularization helps prevent overfitting but does not inherently shorten training time. Transfer learning focuses on leveraging a pre-trained model on training for a new similar task rather than stopping training based on performance. A company is using a machine learning model to detect fraudulent transactions in real time. Over time, the model's performance has been declining. Which of the following is the most likely cause of model drift in this scenario? Option A, excessive load on model. B, changes in model's architecture. C, errors in the training data. Or D, changes in fraud patterns. Option D is the right answer here. As fraud patterns evolve over time, the model may not be able to detect new types of fraudulent transactions effectively, leading to a decline in performance. This is a common scenario in fraud detection systems where the nature of fraudulent activities changes. Other options are not correct. A machine learning engineer is developing a model that predicts customer churn. Despite the model having good overall accuracy, there are false negatives because of a low number of recorded churn cases. The machine learning engineer wants to improve the performance of the model. So how can he do this? Option A, apply random undersampling on the non-churn cases. Option B, apply synthetic minority oversampling technique on the churn cases. Option C, apply random oversampling on the non-churn cases. Or option D, shuffle the data and add noise to it. So option B is the correct answer here. It is a technique specifically designed to address class imbalance problems, which is the case in this scenario, where there are fewer churn cases compared to non-churn ones. Option A reduces the number of non-churn cases but can lead to loss of information. Option C, this might introduce bias and potentially degrade the model's performance on non-churn cases. Option D, this would not address the underlying class imbalance problem and could potentially degrade the model's performance. A data scientist develops a deep learning model for predicting customer churn. The model performs well on training data but poorly on validation data. To improve generalization, he considers regularization techniques. What is the primary benefit of using regularization techniques? Option A, increased model complexity. B, prevention of overfitting. C, reduction of training data requirements. Or D, improvement of feature scaling. Option B, prevention of overfitting, is the right answer here. Regularization techniques such as L1 or L2 regularization or dropout help the model generalize better to unseen data by adding constraints that reduce the model's complexity, thereby preventing overfitting. Other options are not correct. A company is building a machine learning model to classify different types of fruits using images of apples, oranges, and bananas. The machine learning team is using convolutional neural network or CNN on Amazon SageMaker for training. However, during validation, they notice that the model is underperforming when classifying images of oranges with a higher number of misclassifications. The team wants to investigate the cause of these misclassifications to enhance the model accuracy for the orange class. Which approach will help the team achieve this? Option A, use SageMaker Model Monitor to analyze prediction drift. Option B, add more images of oranges to the training dataset and retrain the model. Option C, use SageMaker Autopilot to automatically adjust the model architecture. Option D, use SageMaker Debugger to inspect the internal model state during training. So option D, use SageMaker Debugger to inspect the internal model state during training, is the right answer here. SageMaker Debugger provides visibility into the model's internal states such as tensors, gradients, and activations, allowing the machine learning team to detect issues like poor feature representation or vanishing gradients that could be causing the misclassification of oranges. This approach gives detailed insights into how the model is learning and why certain images are misclassified. Now, option A, Model Monitor, is designed for post-deployment scenarios where you monitor model predictions over time in production, not during training. Option B, adding more orange images could increase data diversity, but it doesn't diagnose the cause of misclassification. It's a general fix that may or may not help. And option C, Autopilot, automates model building but it doesn't offer insights into why specific misclassifications occur during training. Which hyperparameter tuning technique is known for its efficiency in exploring the search space by using prior results to influence future searches? Our options are grid search, random search, Bayesian optimization, and manual tuning. Option C, Bayesian optimization, is the right answer. It uses a probabilistic model to identify promising areas in the hyperparameter space based on previous evaluations. Grid search exhaustively evaluates all combinations of specified hyperparameter values. This is a time-consuming process for large spaces. Random search samples random combinations of hyperparameters, which is more efficient than grid search, especially when some hyperparameters have less impact. Manual tuning involves adjusting hyperparameters based on intuition. It is time-consuming and less systematic than automated methods. What is the key benefit of using SageMaker script mode with frameworks like TensorFlow and PyTorch for model training? Our options are automatic data labeling, custom model training scripts, no need for model evaluation, or inherent model deployment. Option B, custom model training scripts, is the right answer here. SageMaker script mode allows developers to use their own training scripts while leveraging the scalability and managed infrastructure of SageMaker. Other options are incorrect. Match the following explainability techniques to their appropriate use cases. Explainability techniques, line, permutation feature importance, counterfactual explanations. Use cases: generate alternative input instances that would lead to a different prediction. Quantify the change in prediction when a feature is perturbed. Identify the features that most influence the prediction. And here are the explainability techniques matched to their use cases. Line, identify the features that most influence the prediction. Permutation feature importance, quantify the change in prediction when a feature is perturbed. Counterfactual explanations, generate alternative input instances that would lead to a different prediction. Which AWS service provides a scalable solution for data labeling and validation by enabling you to create human-in-the-loop workflows for training machine learning models? Our options are Amazon Mechanical Turk, SageMaker Ground Truth, AWS Glue, or Amazon Comprehend. Option B, SageMaker Ground Truth, is the right answer here. It is a managed service for data labeling that combines automated labeling with human review for machine learning datasets. Amazon Mechanical Turk is a crowdsourcing platform for hiring remote workers to perform various tasks. It lacks specific integration for machine learning workflows that SageMaker Ground Truth offers. AWS Glue is a ETL service not focused on data labeling or validation. Amazon Comprehend is a service for extracting insights from text and not for data labeling. A company wants to build an internal chatbot to answer questions about company policies. The information is in several PDF documents. How can the company make these PDF documents searchable by LLM chatbot via RAG? Select two right answers. Option A, split the documents and ingest them in DynamoDB database. Option B, embed the documents in Amazon Bedrock knowledge bases for RAG. Option C, save the documents in a S3 bucket. Option D, embed the documents in a vector store like OpenSearch. So for use with RAG, we need some form of a vector store, and this is clearly provided by options B and D. Therefore, option B, embed the documents in Amazon Bedrock knowledge bases for RAG, and option D, embed the documents in vector store like OpenSearch, is the right answer. Now option A talks about storing the document in DynamoDB, which clearly does not support vector search, and option C, storing the documents in S3 bucket, also does not help. Which technique involves removing unnecessary weights from a trained model to reduce its size while maintaining performance? Our options are feature selection, data type alteration, pruning, or compression. Option C, pruning, is the right answer here. Pruning eliminates redundant weights or neurons from a model, resulting in a smaller size while preserving its performance. Let's look at other options. Feature selection is about selecting relevant features to improve efficiency. It does not reduce model size. Data type alteration changes data types to save memory. It does not remove model components. Compression is about reducing model size through techniques like quantization or weight sharing. It does not focus on removing components like pruning does. A company wants to deploy a new version of its machine learning model for real-time inference. A machine learning engineer needs to prioritize minimizing downtime and ensure a smooth transition. The machine learning engineer plans to start with a small subset of users and gradually increase the traffic to the new model. Which deployment strategy would be most suitable for this scenario? Our options are blue-green deployment, canary deployment, rolling deployment, or A/B testing. Option B, canary deployment, is the right answer here. Here we gradually shift user traffic to the new version starting with a small subset of users, allowing for monitoring and risk mitigation before a full rollout. In case of blue-green deployment, here we switch all traffic to the new version at once after deployment. So there is no gradual rollout here. Option C, rolling deployment, systematically replaces old versions with the new ones across servers in batches. And option D, A/B testing. This is not really a deployment strategy but a method for comparing two versions by splitting user traffic between them. It is typically used for experimentation and not for deployment. Which metric is specifically used to evaluate the performance of a classification model by considering both precision and recall? Our options are accuracy, F1 score, root mean square error, or area under ROC curve. Option B, F1 score, is the right answer here. It is the harmonic mean of precision and recall, useful for evaluating imbalanced classification models. Option A, accuracy is the ratio of correctly predicted instances to the total instances in the dataset. It is a basic metric but can be misleading in imbalanced datasets. Root mean square error is a metric used for regression models that measures the average magnitude of the errors between predicted and actual values, providing insight into model accuracy. Area under ROC curve evaluates classification models by measuring the trade-off between true positive and false positive rates. Higher values indicate better performance. A data scientist aims to adopt a pre-trained deep learning model for a specialized domain task, but they only have limited labeled dataset available. Which approach would provide the most effective balance between leveraging existing knowledge and improving model performance on the new task? Our options are A, transfer learning with some frozen layers, B, full model training from scratch using the limited dataset, C, use self-supervised learning, or D, augment the limited dataset using data fusion. Option A is the right answer here. Transfer learning with some frozen layers involves using a pre-trained model, freezing some layers and fine-tuning others. This approach leverages existing knowledge and reduces overfitting. Let's look at other options. Option B, full model training from scratch means training a model solely on the limited dataset. This method is prone to overfitting and poor generalization. Option C, self-supervised learning learns representations from unlabeled data through self-generated tasks. However, it typically requires substantial unlabeled data and may not adapt well to this specific task. Option D, augmenting the limited dataset using data fusion enhances the dataset by combining it with other data sources or transformations. While this improves robustness, it does not leverage pre-trained knowledge effectively. What metrics in SageMaker Clarify helps identify potential biases in training data by comparing distribution of features across different groups? Our options are data bias metrics, model accuracy metrics, data quality metrics, or feature importance metrics. Option A, data bias metrics, is the right answer here. It is used to evaluate and compare feature distributions between different groups to detect potential biases in the training data. These metrics can help detect disparities that may lead to biased model predictions. Model accuracy metrics measures a model's overall performance, such as accuracy, precision, recall, F1 score, and AUC. Data quality metrics assesses the overall quality of the training data, such as completeness, accuracy, consistency, and relevance. Feature importance metrics identifies the most influential features in a model. Your organization is deploying a machine learning model in a VPC that will receive requests that are about 5 MB in size and response can take 10 to 15 minutes. Which endpoint type or solution would be most cost effective for this scenario? Option A, SageMaker real-time endpoint, B, batch transform job, C, serverless endpoint, or D, asynchronous endpoint. Option D, asynchronous endpoint is the right answer here. Since the response can take a long time, it makes sense to use an asynchronous endpoint. Option A, real-time endpoint is for scenarios where we need response in real time, and batch transform job is for scenarios where we need to process dataset offline, large datasets. And option C, serverless endpoint can scale automatically. However, it can incur higher costs for response that takes a long time. A data scientist needs to update a previously tuned machine learning model with new data. Which technique would be most efficient for this? Our options are A, transfer learning with maximum training job limit, B, transfer learning with auto early stopping, C, identical data and algorithm with decreased training jobs and auto early stopping, or D, random search with auto early stopping. Option B, transfer learning with auto early stopping is the right answer. It fine-tunes a model on new data and stops training when performance plateaus, therefore making it efficient and effective for updates. Let's look at other options. Transfer learning with maximum training job limit adapts a pre-trained model to new data but may stop prematurely due to training job limit. Identical data and algorithm with decreased training jobs and auto early stopping reuses the same data and algorithm but limits training jobs, sacrificing the benefits of transfer learning and effectiveness in adapting to new data. Random search with auto early stopping uses random hyperparameter tuning with early stopping to save time but is less efficient than transfer learning for model updates as it doesn't leverage prior training effectively. A financial services company deploys a machine learning model on Amazon SageMaker to assess loan risk and approve personal loans. The model currently prioritizes credit score over income. The company wants to monitor for any shift in this prioritization. Which SageMaker model monitor component would be most suitable? Option A, model bias monitor, B, model explainability monitor, C, data quality monitor, or D, model quality monitor. Option B, model explainability monitor is the right answer here. This component uses SHAP to explain model predictions, revealing feature importance. It can detect if the model's reliance on credit score shifts over time. Option A, model bias monitor. While this can detect bias, it's not specifically designed for monitoring feature attribution like credit score and income. Option C, data quality monitor. This monitors data quality, not model behavior or feature importance. Option D, model quality monitor. This assesses overall model performance, not specific feature importance changes. A machine learning team is developing a model to classify images. They find that the training dataset has a significant class imbalance with many more dog images than cat images. To assess the bias in this distribution compared to a desired uniform distribution, which metric should they use? Our options are total variation distance, Kullback-Leibler divergence, difference in proportion of labels, or class imbalance. Of these, option B, Kullback-Leibler divergence, is the right answer. It quantifies how one distribution diverges from another, showing the information lost when approximating one distribution with another. Let's look at other options. Total variation distance measures the maximum difference between two probability distributions, indicating how much they diverge. Option C, difference in proportion of labels, calculates the absolute difference in class proportions. It is useful for understanding class imbalance. Option D, class Imbalance describes the ratio of classes in a dataset, indicating overrepresentation, but not providing a statistical divergence measure. A financial services company is using an Amazon SageMaker endpoint to serve predictions from its machine learning model. With an upcoming marketing campaign, they anticipate a significant increase in traffic, raising concerns about latency with the current request count-based scaling policy. What adjustment should the operations team make to ensure optimal performance during the campaign? Option A. Disable the current scaling policy if any. Option B. Change the target value in the current scaling policy. Option C. Switch to a step scaling policy to better manage sudden traffic spikes. Option D. Set up a scheduled scaling policy to boost capacity before the campaign. Option D is correct here because it proactively adds capacity ahead of the expected traffic spike, and that minimizes latency. None of the other options address this proactive scaling requirement. A machine learning engineer is evaluating a model's performance. The model performs well on training data but poorly on test data. What is the most likely issue and how should they address it? Our options are: A. The model is overfitting. They should reduce its complexity or use regularization techniques. B. The model is underfitting. They should increase the model's complexity or collect more data. C. The model is underfitting. They should reduce the learning rate to improve accuracy. D. The model is overfitting. They should increase the number of training epochs to improve test performance. Of these, option A is the right answer. Overfitting occurs when the model learns the training data too well and fails to generalize on new data. So reducing complexity or applying techniques like dropout or L2 regularization helps. Other options are not correct. A media company wants to automatically generate subtitles for its video content in multiple languages. Which combination of AWS AI services would be most effective for this task? Option A. Amazon Recognition and Amazon Translate. Option B. Amazon Transcribe and Amazon Recognition. Option C. Amazon Transcribe and Amazon Translate. Option D. Amazon Bedrock and Amazon Recognition. Option C. Amazon Transcribe and Amazon Translate is the right answer here. Transcribe generates text from speech and Translate converts it into multiple languages. Option A is incorrect because Amazon Recognition is used for image and video analysis but not for generating or translating text. Option B is incorrect because while Transcribe generates text from speech, Recognition is not used for translation. Option D is incorrect because Bedrock offers foundation models, but this combination does not directly solve the problem of subtitle generation and translation. A financial institution is developing a credit scoring model and is concerned about biases in the training data that could lead to unfair lending practices. Which combination of AWS services should they use to effectively identify and mitigate selection and measurement bias? Our options are: A. SageMaker Clarify and SageMaker Data Wrangler. B. SageMaker Clarify and Amazon Personalize. C. SageMaker Debugger and AWS CloudTrail. Or D. SageMaker Ground Truth and SageMaker Studio. Option A. SageMaker Clarify and SageMaker Data Wrangler is the right answer here. Clarify identifies and mitigates bias while Data Wrangler prepares data ensuring fairness and representativeness. B is incorrect because Personalize focuses on recommendations and does not directly address bias in credit scoring. Option C. Debugger monitors training but doesn't address bias. CloudTrail tracks API calls that's unrelated to bias mitigation. Option D. Ground Truth aids in data labeling and Studio is for model development, not specifically for bias identification. A retail company wants to improve its machine learning models due to changes in customer behavior over time, leading to concept drift in their numeric text and image datasets. Which of the following strategies would be most effective for addressing this issue? Select 2. Our options are synthetic data generation, feature selection, resampling techniques, or data normalization. Of these, Option A and C are the right answers. Synthetic data generation involves creating new data points to reflect changing patterns in the dataset, helping the model adapt to new conditions. Resampling can help adjust the dataset to better reflect current trends by either upsampling underrepresented classes or downsampling overrepresented ones. Feature selection is primarily used to reduce the dimensionality of the data and improve model performance, but it doesn't directly address concept drift. Data normalization is a pre-processing step that scales the data to a specific range, which is important for certain machine learning algorithms, but doesn't address the issue of changing data distributions over time. You are preparing a machine learning model to predict house prices. The dataset contains features with varying ranges, skewed distributions, and mixed data types. Which of the following feature engineering techniques would be most suitable to improve model performance? Select two right answers. Our options are data scaling and standardization, feature splitting, log transformation, or binning. Of these, option A, data scaling and standardization, and C, log transformation are the right answers. Data scaling and standardization is useful for normalizing features with different ranges, making it easier for the model to learn effectively. While log transformation helps normalize skewed distributions, making features more symmetric and improving model performance. Let's look at other options. Feature splitting. While helpful for splitting composite features, it may not directly address varying scales of distribution. And binning is primarily used for turning continuous variables into discrete bins, but it doesn't solve issues with scaling or skewed distributions. A retail company wants to analyze customer emotions from product review videos, including both visual emotions from faces and sentiment of spoken feedback. Which combination of AWS AI services can best achieve this? Our options are A. Amazon Recognition, Transcribe and Comprehend, B. Recognition, Translate and Comprehend, C. Recognition, Poly and Comprehend, D. Recognition, Translate and Transcribe. Of these, option A, Amazon Recognition, Transcribe and Comprehend is the right answer. Let's go over each of these services to understand what they do. Amazon Recognition detects faces and visual emotions like joy, sadness, and surprise from images or videos. Transcribe converts audio into text. Comprehend can analyze text for sentiment analysis. Translate automatically translates text between languages, and Poly converts text to lifelike speech. Therefore, in option A, Amazon Recognition can be used to detect visual emotions, and Transcribe to convert audio into text, and Comprehend to find sentiment from that text. A company is building a machine learning pipeline to process video files for object detection. The company receives daily video uploads, and the videos are stored in Amazon S3. The videos need to undergo pre-processing steps such as frame extraction, resolution adjustment, and format conversion using frameworks like OpenCV. The pre-processed data will then be used to train the machine learning model. Which combination of steps will meet these requirements with least operational overhead? Select three right answers. Option A, use Amazon EMR to process the videos in parallel. B, enable Amazon S3 event notification to trigger processing when new videos are uploaded. Option C, create a processing job on Amazon SageMaker to pre-process the data. Option D, use AWS Lambda to extract video frames and store them in S3. Option E, use Amazon step functions to orchestrate the pre-processing tasks. And F, use AWS Glue ETL jobs to process the videos. So option B, C, and E are the right answers here. So we need a S3 event notification to start our process when a video arrives, and a processing job on SageMaker to pre-process the data, and we could use step functions to orchestrate all the tasks. So option A is not correct because it introduces unnecessary complexity which is not needed here. Then option D, Lambda is not ideal for long running tasks like video processing. And option F, Glue is good for ETL tasks involving structured data, not for video processing. So it's not the best tool for the job. A healthcare organization wants to analyze patient medical records to identify potential risks and improve patient outcomes. However, due to privacy regulations, they must ensure that patient data remains anonymized. Which solution would be most efficient for processing and anonymizing patient data? Our options are A. Use a text-based search and replace algorithm to remove personally identifiable information or PII. Option B. Extract and anonymize patient data using Amazon Textract. C. Build a custom anonymization model using Amazon SageMaker Canvas. Or D. Use Amazon Comprehend for automatic PII detection and redaction. Option D, using Amazon Comprehend, is the right answer here because it is pre-trained for PII detection and therefore it is efficient and accurate. Other options either require custom effort or have limited capability to identify PIIs. A company is deploying machine learning models and wants to analyze and optimize their machine learning infrastructure costs. Which AWS tool would provide detailed cost insights including forecasting, cost trend analysis, and recommendations for reducing machine learning infrastructure expenses? Our options are AWS Trusted Advisor, AWS Billing and Cost Management, AWS Cost Explorer, or Amazon SageMaker Studio. Option C, AWS Cost Explorer, is the right answer here. It is a detailed cost analysis tool that offers cost trend analysis, forecasts, and recommendations for optimizing expenses, including machine learning infrastructure. Trusted Advisor provides best practice recommendations, including cost optimization, but does not offer detailed cost insights and forecasting like AWS Cost Explorer. AWS Billing and Cost Management is primarily used for managing payments, budgets, and invoices rather than providing cost trend analysis and forecasts. Amazon SageMaker Studio is a development environment for building, training, and deploying machine learning models, not a cost analysis tool. A healthcare company has a machine learning model for real-time, low-latency patient risk prediction. The model receives no more than 20 concurrent requests and is currently hosted on-premises. The company wants to host the model on AWS but does not want to manage the infrastructure that is servicing the models. Which solution will deploy the machine learning model with least effort? Option A, use Amazon ECS to deploy the model as a container. Option B, use Amazon EKS to deploy the model as a Kubernetes cluster. Option C, deploy the model as a SageMaker model endpoint. And option D, deploy the model as a SageMaker model endpoint with asynchronous processing. So option C, deploy the model as SageMaker model endpoint, is the right answer here. This is the simplest option, providing automatic scaling, infrastructure management, and low latency. Option A requires more effort as it involves building and managing a container. Option B requires more overhead in managing a Kubernetes cluster. And option D is suitable for batch processing or non-real-time tasks, but it's not suitable for real-time low-latency applications. A data scientist is training a deep neural network for image classification. They set the learning rate to 0.1 and the model's loss fluctuates significantly between epochs, showing no clear signs of improvement. What is the most likely cause of this behavior and what should they do? Our options are A. The learning rate is too high. They should reduce it to allow model to converge more smoothly. B. The learning rate is too low. They should increase it to speed up convergence. C. The batch size is too small. They should increase it to stabilize the training. D. The learning rate is optimal. They should add more training data to stabilize the loss. Of these, option A is the right answer. A high learning rate causes large updates leading to oscillation and instability in training. Therefore, this is the correct solution. Other options are not correct and they do not help. A data scientist is developing an image classification model using Amazon SageMaker. To efficiently handle varying input image sizes, and quickly iterate on improvements based on performance metrics. Which combination of SageMaker features should they leverage? Our options are A. SageMaker Canvas for data analysis and SageMaker Endpoint for predictions. B. SageMaker Ground Truth for labeling and SageMaker Debugger for performance analysis. C. SageMaker Processing for pre-processing and hyperparameter tuning for optimization. Or D. SageMaker Studio for collaboration and SageMaker Pipelines for integration and deployment. Of these, option C, SageMaker Processing for pre-processing and hyperparameter tuning for optimization, is the right answer. SageMaker Processing allows the data scientist to efficiently pre-process images, ensuring the model can handle varying input sizes, and hyperparameter tuning optimizes model parameters, enabling faster iterations and better performance based on metrics. Other options do not directly address pre-processing images and efficient iteration. A healthcare organization wants to ensure that features used in their machine learning models are consistent across training and inference. They plan to use historical patient data for model training and real-time patient data for inference. Which approach should they take using Amazon SageMaker? The options are A. Store features in Amazon DynamoDB for fast access. B. Use Amazon SageMaker Feature Store to manage and version features. C. Rely solely on Amazon S3 for feature storage. Or D. Train the model only with batch data. Of these, option B is the right answer. Amazon SageMaker Feature Store is a fully managed service that enables developers and data scientists to easily store, manage, and retrieve features for machine learning models. Other options are not correct because they do not help with feature management. You are evaluating a text summarization model on various tasks related to summarizing long documents. To assess the quality of the generated summaries, which evaluation metric best measures their semantic similarity to the original text? Our options are BERT score, BLUE, Perplexity, or Rouge. Option A, BERT score, is the right answer. BERT score is the most suitable metric for evaluating semantic similarity of text summaries to the original text, as it considers the context of words and phrases and aligns most closely with human judgments of text quality. BLUE, or Bilingual Evaluation Understudy, is a metric used to evaluate the quality of text which has been machine translated from one language to another. Perplexity measures the complexity of a language model, how well a model can predict the next word or character in a sequence. Lower perplexity means the model is better at making predictions. Rouge, or Recall-Oriented Understudy for Gisting Evaluation, is specifically designed for evaluating text summaries. You are a large enterprise with a vast collection of customer support tickets. You want to provide your customer support agents with a powerful search tool that can quickly find relevant tickets based on natural language queries and keywords. Which AWS service would best meet this need? Our options are Amazon Redshift, Lex, RDS, or Amazon Kendra. So option D, Amazon Kendra, is the right answer here. It uses machine learning to index and search across data, providing highly relevant answers to natural language user queries and not just keyword matches. Redshift is a data warehouse service primarily used for analytical workloads. Lex is a service for building conversational interfaces, and RDS is a relational database service. A company is using Amazon SageMaker to build predictive models to forecast daily sales. A data science team wants to generate a new set of predictions at the end of every day using SageMaker pipelines to automate the inference process. Select and order the correct steps from the following list to meet these requirements most cost effectively. Select and order 3 options. Option A, create SageMaker pipeline to perform daily batch inference. Option B, create a SageMaker pipeline to use real-time endpoint for daily predictions. Option C, use SageMaker Clarify to explain model predictions. Option D, grant Amazon Event Bridge the necessary permissions to execute the SageMaker pipeline. And option E, configure Amazon Event Bridge to trigger the pipeline daily. Of these, option B and C are clearly not correct because option B refers to using a real-time endpoint, and our scenario is to generate a new set of predictions at the end of every day. So it's not real-time. Okay, so option B is not correct, and option C, use SageMaker Clarify to explain model predictions. Our use case does not talk about explaining model predictions, so therefore that too is not correct. So option A, D, and E are the correct options, and we need to arrange them in the right order. And the correct order is A, E, and D. So first create SageMaker pipeline to perform daily batch inference, then configure Amazon Event Bridge to trigger the pipeline daily, and then grant Amazon Event Bridge the necessary permissions to execute the SageMaker pipeline. You are building a machine learning model and need to follow a sequence of steps to pre-process the data before training. Select and arrange the first 3 steps in correct order. Option A, split the dataset into training and test sets. B, normalize or standardize the features. C, handle missing data. Or D, train the machine learning model. So the correct options in the right sequence are C, A, and B. You would handle the missing data, split the dataset into training and test sets, and normalize or standardize the features. A company is deploying machine learning models on edge devices and needs a solution to optimize these models for performance and efficiency. Which SageMaker service should they use? Our options are SageMaker Neo, SageMaker Data Wrangler, SageMaker Clarify, or SageMaker Ground Truth. Option A, SageMaker Neo, is the right answer here. It is specifically designed to compile and optimize machine learning models for deployment on edge devices, ensuring optimal performance and efficiency. SageMaker Data Wrangler is a tool for data preparation and feature engineering, allowing users to clean, transform, and visualize data before training models. SageMaker Clarify is a service that helps with data and model explainability, providing insights into data bias and model predictions to ensure fairness and transparency. SageMaker Ground Truth is a service for building labeled datasets, enabling users to create and manage training data efficiently through human labeling and automation. An AI assistant is trained on new tasks like booking flights but starts performing poorly on a previously learned task such as managing calendars after the new training. What is this issue called and how can it be mitigated? Our options are A, overfitting, mitigated by reducing model complexity. B, underfitting, mitigated by increasing training epochs. C, catastrophic forgetting, mitigated by replaying examples from previous tasks. Or D, data imbalance, mitigated by oversampling tasks with fewer data. Option C is the right answer here. So this is a case of catastrophic forgetting. Replaying examples from earlier tasks or using regularization techniques can help the model retain knowledge from prior tasks. Other options are not correct. A company is deploying a machine learning model on an edge device with limited memory and processing power. Which 2 techniques can be used to reduce the model size without significantly sacrificing performance? Our options are A, convert the model's weights to lower precision data types such as from float 32 to float 16. B, prune unnecessary neurons or connections in the model to remove redundancy. C, add more features to the training data to improve model's accuracy. Or D, increase the number of layers in the neural network to enhance its capacity. Options A and B are the right answers here. So converting weights to lower precision reduces memory usage and computation requirements. And pruning reduces the number of neurons or connections, shrinking the model size while retaining important information. Option C and D would increase complexity or size, which would defeat the goal of reducing the model size. A company wants to effectively monitor and manage costs for their machine learning infrastructure on AWS. Which 2 strategies should they implement? A, tag all AWS resources used for machine learning. B, use AWS CloudFormation to deploy machine learning resources. C, set AWS budgets for cost thresholds based on tags, or D. Consolidate machine learning resources under one account. Options A and C are correct. Tags help us identify resources of interest which AWS budgets can use for cost thresholds. Option B and D do not effectively address cost monitoring. A data scientist is using AWS Glue Data Brew to prepare data for a customer churn prediction model. Which of the following tasks would be most likely performed in Data Brew? Our options are A. Building a machine learning model, B. Identifying customer segments, C. Cleaning and transforming customer data, or D. Evaluating the model's performance. Option C is the right answer here. AWS Glue Data Brew is primarily designed for data preparation tasks such as cleaning, transforming, and preparing data for analysis. It is not used for building machine learning models or identifying customer segments or evaluating performance.